So then having the cell and the water and obviously getting together, how do you actually get the cell to work?
That's a three stage process. The first thing is to have your cell assembled properly and clean. To put in a charged water, where the water has been processed and electrically charged. When we first pour the water into the cell, we then go through a stage of energising the cell, which is applying a voltage for a given time and duration, and at given intervals according to the formulas, the charge power formula. Um, and we charge the cell until its half-life, which is another one of the formulas, until its half-life stops extending. In other words, we have a fixed half-life. At that point, tip out the water. It's always got contaminants in it, mainly contaminants from the surface of the stainless. Put in fresh water, and it's time to start using the energy from the cell in the running of an engine.
And is that all you need to do? Is it a sealed thing that the water contained in it lasts forever, or does it evaporate away? Or
A cell can't be sealed. It would probably be wonderful if it could, but it simply cannot. In electrolysis, we create gases. There's hydrogen and oxygen are the primary gases. Not a lot of gas, certainly not enough to run an engine in any fashion. Even the smallest engine couldn't run. So for people that think that we've got a hydrogen generator, not happening, nowhere near enough. If we had no means of that gas getting out, there would be enough to create pressure and eventually the cell would explode. So we do have to have a vent, and that vent must be fed through a HHO or hydrogen flashback arrestor, so that the gases that are produced can be vented from the cell safely. And in my case, I always run the output of the flashback arrestor into the engine's inlet manifold and feed it into the vacuum. Disposes of it quite nicely, and it gets consumed in the engine. Having said that, I've done a number of tests where I've disconnected that vacuum or closed it off at the engine end, and I'm more than satisfied that it's having no measurable effect on the engine. We're not using any energies associated with the gas.
then, so here we have a fuel cell which is producing deuterium, which actually gets the motor to work. How does that get to the motor, and how does it work within the motor?
Okay, well, my theory is that at the point of electrolysis, we've got gases coming off of what are effectively the two electrodes, the cathode being the centre of the cell, and the anode is the outer case. At the point where the gas is coming off of the outer case, which is positive, we've got oxygen gas being produced. And against the stainless steel wall of the case, we have effectively hydrogen enriched water. I believe that the positive voltage applied to permit the electrolysis attracts the hydrogen, and when I say hydrogen, we're possibly talking deuterium, is being attracted into the molecular structure, the crystalline structure of the steel itself, and migrates through the structure toward the source of the voltage. Now, coming off the top of the cell, we have a connection device to the engine. For the most part, in the past, that has typically been a tube, 1 inch round, a fairly heavy walled tubing, where people were thinking that it was a gas that was actually going through the tube, although that tube was not vented into the engine. It was going to a blind connection on the engine, meaning that the point where the tube met the engine, there was no hole going through. We were simply presenting this gas to a blind plug. I then thought one more, and well, okay, is it actually a gas at that point? Is it travelling through the hole or through the metal? Another test that I did lead me to the conclusion that it actually migrates through the steel itself. And one move on from the tube was the use of a heavy aluminium cable, and I currently use about a 14mm outer diameter 19-inch strand aluminium cable to connect the cell to the engine. Now, we have a gap at the engine end, as explained in detail in the book. But what we do is we use the voltage which is connected at the engine end of the cable, and that attracts this energy along the cable, right up to the point of the engine where it travels over a small gap into the block itself, or the cylinder head.
Mm-hmm.
And then over time, dopes the entire engine's metal with the hydrogen deuterium mix. And again, I refer to it as hydrogen deuterium because I really don't have a method of telling you exactly what it is.
Right.
It simply fits with what I believe to be the operation of the engine.
Then, once this is within the engine, within the metal itself, how does it then work to combust air?
Okay, well, what I believe happens is a little different to many of the other theories that have been presented. It's just my theory. I believe that we end up with our combustion chamber effectively being totally doped with hydrogen deuterium, so that all surfaces are effectively wet with these elements.
Mm-hmm.
When we then combust or start to compress atmosphere, which is all we're sucking into the engine, just air, at about 2.5 atmospheres we then spark. Where ignition timing is no longer a few degrees before top dead centre. It's around 70 degrees, and I've had an engine running at 85. So the piston's just over halfway up the stroke. The spark happens. That would seem to create an implosion.
Mm-hmm.
Now, there are suggestions, and I've read information that suggests that if we ignite nitrogen in a hydrogen-enriched environment, which is what we really have with air in this enriched combustion chamber, we get what is called an endothermic reaction, which is an implosion. Now that implosion would certainly explain for the effect of compression being removed, the fact that the engine can turn over so slowly and so easily. That implosion would draw the piston up and possibly also make the valves leak. In a normal four-stroke engine, valves are intended to seal under compressions, not under vacuums.
True.
So it also sucks in more atmosphere that was intended to go into the chamber. And the other interesting point with an endothermic reaction is that endothermic reactions consume the heat of the implosion. That would also explain why so many people have reported these engines running cold. Now, I've personally had a readout of 70 degrees C on the exhaust of my generator. 70 is not that cold. You can put your hand on it, but you wouldn't want to leave it there for too long.
When you say a generator, you're using a petrol-driven motor on a generator as your test bed, are you?
Yeah, I've got a small Kawasaki 1500 watt four-stroke single cylinder generator.
Mm-hmm.
I favour going for a generator situation because firstly it's easy to put on the bench and work with. Secondly, because it's a generator, we can connect loads to it, and therefore we can measure the energies that we're producing and apply that to some normal formulas of what petrol would go in for that amount of kilowatts out and so on. So a generator seemed to be a poor man's perfect way of testing.